Hello, my name is Bill Birmingham. I work with the Napa County Resource Conservation District, and I'd like to spend some time today discussing with you some best management practices to better storm-proof your unpaved roads. A lot of what I'll be discussing today can be found in the Handbook for Forest and Ranch Roads. You can Google Mendocino RCD, go to their publications page, and be able to either purchase this book or download a PDF version for free. It comes in both English and Spanish. And of course, with all roads maintenance practices, I want to recommend that you call before you dig to make sure that you don't disturb any underground utilities. Just before we get started, let's go over a couple brief road terminology that I might use throughout the presentation. Cut bank is usually the cut portion of the roadbed that's cut into the natural hillside. Oftentimes you'll have an inboard ditch or a road ditch. We all have a road bed or road surface. And then there's the outboard road or the fill slope portion of the road that's been used to achieve the width of the road that you use to travel. On properties, you might find a variety of different stream crossing types, whether they be bridges or fords or fills. But for today's discussion, we're mostly going to look at culverted stream crossings and what we can do to better storm-proof those types of stream crossings. Culverts can be just looked at more so as a earthen dam with a hole in it that's draining your stream system. And when we put those fills across our stream channels, we can run into a lot of potential for those to fail or plug for various reasons. Interesting study that some folks did back up in Mendocino and Humboldt County a few years back looked at the failure mechanisms of culverted stream crossings, and it was interesting that it was woody debris that was the majority of the cause of those crossings to plug or fail. Looking at this pie graph, it's roughly 61, 70, about 80% of the reasons why the culverts failed was due to woody debris. Also interesting to note in their study is that they looked at the size of the woody material that was flowing down the channels, and 99% of the woody material coming down the channel was shorter than the active channel width. So it doesn't take a lot of big sticks to cause some problems at these culverted stream crossings. In these photos, you can see in the photo to the left, you've got some wood and sticks starting to accumulate there at the inlet, starting to reduce its capacity, and then over time, more and more sediment, more and more wood collects there, and therefore you have a culvert that's no longer functioning or getting ready to fail. One of the treatments that we recommend for that is what we call the single post trash rack. This is a typical drawing of a single post trash rack. It can be found in that Forest and Ranch Roads Handbook. Basically walks you through the basic designs of how to install one of these single posts at your culverts. And the purpose of the single post is to hopefully, as this woody material comes down the channel, it can deflect off that single post and orient itself parallel and have a chance to travel through the culvert rather than plugging the inlet. The other component of these single posts is that if the woody material doesn't have a chance to do that, it can raft itself along the post, leaving the inlet of the culvert open and allowing you to maintain and clean that area. Caveat to that treatment is I want you to think about is if you have an elbow or a turn in the interior of your culvert. If you have an elbow or a turn in your culvert, you really don't want that woody material to go down into your culvert because it's going to be very difficult for you to maintain. So in those types of instances, I would discourage you from putting in the single post trash rack, allowing the woody material to plug at the inlet where you have access to it and are able to maintain it. So that's just something for you to think about out there on your property. While you're down there for the single post trash rack installation, take a look at the condition of your culvert, see if it's crushed at the inlet or if the bottom has been rusted out. These types of features would indicate to you that maybe the culvert needs replacement sometime in the future. With metal culverts, they will rust over time, and you can assume that they have about a 30 or 40-year lifespan once they've been installed. Also, the rust line at the inlet can indicate to you what your average flows are at that crossing. And if you have a rust line that's about 50% up the sides of your culvert, you can start to assume that maybe that pipe is undersized for the amount of drainage area that it's draining. Give you some ideas about future maintenance needs. So that was covering plug potential at culverts and their inlets. And then the next thing that we want to think about or discuss is diverted stream crossings at culverts. In this photo on the left, I don't know if you can see it there, but there's a person standing here where this culvert was, and then it plugged, and now the flows are going down the roadbed, causing outboard fill failures. In this photo here, what has happened is the culverted stream crossing failed, traveled down the road, plugged the next culvert, and then continued to do that work further down the roadbed, causing this excessive erosion. In all these instances, we can assume that we're going to get significant gulling and sediment transport in our watersheds, which would be negatively impacting water quality. So what we want to do is try and prevent these crossings from diverting when or if they plug during these storm events. Here's a sort of a graphic for you to kind of help you determine whether or not your stream crossing has diversion potential. In both of these upper scenarios, the roadbed continues as a downhill grade across our culvert. You would be standing here looking at the inlet of your culvert. So if this culvert were to flood onto your roadbed, it would divert down the left road reach, and in this scenario, it would divert down your right road reach. But in this bottom scenario, we can see that both our road lengths are coming down to our culvert. So in this scenario, we do not have diversion potential, meaning that if this flows were to flood onto the roadbed, they would cross the road and continue down in their natural channel. So in the scenarios where you would have this diversion potential, again, here's a typical drawing for you that can be found in that Forest and Ranch Roads Handbook. What we advise is on that lower or downhill side of your culverted stream crossing, constructing what's called a critical dip. And what the function of that critical dip is that when those flows have a chance to get onto the roadbed, it orients them back into their natural channel versus diverting down your roadbed, causing further water quality concerns as well as maintenance needs that you would have to do. This typical drawing does go through quite a bit of detail on helping you to figure out the design of these critical dips. We found them to be quite helpful in reducing overall maintenance needs at these crossings. So here we have both the trash rack and the critical dip in a real world setting, what we commonly refer to as failsafe mechanisms. The roadbed's been dipped out through the center axis of the stream so that it can orient the flows back into the natural channel. And then we have the single post trash rack at the inlet to help orient that woody material coming down the channel and passing through the culvert. Not to get too much into culvert designs and culvert replacements, because it does involve a little bit of engineering at times, and also can get you increase in cost because there may be some CEQA review required and then permits as far as stream alteration goes. But just want to touch base on this real quickly because it might give you some ideas for your own property. A lot of properties have these older culvert infrastructure on relatively low use roads at streams that are really only flowing for a couple weeks or maybe a month or so throughout the winter seasons. And in those types of settings, I think that this, what we call the armored fill crossing, might be a better recommendation for those types of settings. As you can see here, the bulldozer is dipping the roadbed out significantly through the crossing, which is helping with that diversion potential issue. We're placing significantly large rock armor at the base of this fill and building up to smaller size range to the outside edge of the roadbed. And then you can see in the wintertime, our flows are allowed to travel across the roadbed. The nice thing about this armored fill crossing is you've reduced that diversion potential. You've gotten rid of the plug potential because you no longer have a top to this stream crossing design. It's not going to rust out or separate over time like culverts can. And the other nice aspect about these armored fill crossings is that everything is visible to the user. As you drive by here, you can see all the elements of the armored fill crossing, and you can notice if there's maintenance that needs to be done. When you put things into a culvert, you don't know how that culvert's functioning, how much rust it's experiencing, or if it's separating until it fails on you, and then you have an emergency situation in which you need to come up with a fix. This is a typical drawing, again, found in the Forest and Ranch Roads Handbook. It basically walks you through the basic elements of replacing that culvert with these armored fill crossings. So we've talked a little bit about culverted stream crossings and a way to storm-proof them or install some fail-safe mechanisms. But now I want to get into road lengths draining down to those stream crossings and some practices that we can implement to help reduce sediment as well as flow to our streams. With road lengths coming down to culverted stream crossings, we see here that we have sediment delivery coming down both our left inboard and our right inboard ditches, but we also have increased flows that are coming into this location. And so when you have a lot of road infrastructure on a rural or wildland setting like this, we're starting to concentrate more flow into our stream channels than they would have historically experienced during that storm event. And so now our streams are having to carry more water relative to the rainfall, and our stream systems have to adjust to that, which often means channel incision and bank failures to accommodate for those larger flows. So with the treatments that we're going to discuss here in this next section, we'll be reducing the amount of flow that's going into these stream crossings as well as the amount of sediment. So it's sort of a two birds with one stone benefit by implementing these following treatments. This is a before and after scenario looking at a road length that's draining to a stream system. In the before scenario, we have a flat or an insloped road bed. We've got some wheel ruts most likely on the road bed itself. We have an inboard ditch, and we have a berm that's built up along the outside edge of the road. That berm is most likely the result of grading over time, where the material comes off the outside edge of the blade of the grader and therefore collects on the outside edge of the road. All of these elements are contributing to concentrating flow and sediment delivery to that stream crossing. What we want folks to do is think about trying to get that road bed to disperse more frequently. And so what we've done here in the after setting is we've outsloped the road, we've removed the berm, we've filled in that inboard ditch, and we've constructed cross drains, or in this instance, rolling dips, to frequently drain the road system rather than have it all concentrate and deliver to one location. The nice element about these cross drains and this outslope is that now we're getting the water to disperse, drain off into our hillside on the downhill side, hopefully recharging the groundwater system, making for a less flashy watershed, as well as reducing the sediment inputs into the stream. Also, because we're draining the roadbed so frequently, hopefully that'll result in reduced maintenance requirements for you because you're not allowing water to erode your road. I'll point out to here in this after photo, you can see that the road is much wider than in the before photo, and that's because we filled in that inboard ditch and gotten rid of that berm. It's not a bigger road, it's the same width of the road before, we just have a much larger driving surface. In this instance, the landowner decided to rock that entire road width surface, but I would recommend only really rocking about 12 feet wide, and then over time that outside edge will revegetate and you really won't notice how wide the road is. Here's a typical drawing, again found in the Forest and Ranch Roads Handbook, that walks you through the design elements of these rolling dips, as well as discusses with you the relative spacing that you should be thinking about for the construction of these dips. So the spacing of the dips is very important. This is a scenario here I wanted to briefly show with you. We have a landowner that had a gully developing on their roadbed. Had they only constructed one rolling dip to dewater that gully, they most likely would have caused just another gully to develop here. So when we start to look at these point locations where we're seeing erosion or maintenance concerns, we really have to think about the entire influence of the roadbed and continue to implement those treatments so as that we don't cause further gullying or erosion at a single point location. Rolling dips can be pretty difficult to photograph and show in photos because the lighting makes them look so flat. So this is about the best photo I have of a rolling dip to really show you how broad these can be and how high this top of the hump or reverse grade is relative to the trough. In this setting, we had a landowner that had an inboard ditch that was grass lined that continued to drain down to their pond, and we didn't want to cut off that ditch flow to recharge their pond with water. So what we've done here is just construct the rolling dip to drain the road surface, and the rolling dip is draining to the outside edge of the road. But you can tell in this photo that the dip between the trough and the top of the crest is a significant height, and so therefore if these rolling dips are constructed properly, you shouldn't have to maintain them on an annual basis. They should be on the landscape on more of a decadal basis doing the work for you to help drain your roadbed. On this setting, this is a vineyard property, as you can see, and they use a tractor or a crawler to haul out grape bins, and so they have a trailer with bins on the back, and so we wanted to produce a nice, broad, long rolling dip for them in order to accommodate those wheelbases and allow for travel on that roadbed. For myself, when I'm overseeing implementation of roads projects, if I can drive a road with rolling dips on my truck at about 10 to 12 miles an hour, I feel like that is a well-shaped rolling dip. Rolling dips work really well until you get to about a 15% road grade, and then at that point you have to start looking at your traffic constraints, whether it's trucks with trailers, two-wheel drive vehicles, or four-wheel drive trucks. In those types of settings where we're starting to get into the steeper road beds, what we recommend is what's commonly referred to as a Type 3 rolling dip. Again, this typical drawing can be found in the Forest and Ranch Roads Handbook, but it doesn't have that hump or that reverse grade like we saw in the previous photo. This is more of a broad scallop or strong outslope through just a portion of the roadbed to help drain it. Again, this would be installed at that same frequency as the other rolling dips, about 150 to 200 foot spacing, so that we don't get any gullying developing at the outlets. And finally, to drain our road beds, we get to what I commonly refer to as the dreaded water bar. Water bars are quite common. We've all been constructing them for decades out there on our road beds. But they're dreaded because nobody really likes to drive over a water bar. They're really difficult and jarring. The other aspect of a water bar is that really all it takes is one vehicle to pass over this water bar during saturated conditions, and then the wheel ruts will now take out the function of the water bar because the water's going to bypass the water bar and continue down the wheel rut, concentrating on your roadbed and causing this to fail. Myself personally, if you're constructing water bars on roads, you're basically saying that we're not going to be traveling these roads during the rainy season. They are fairly efficient if we can keep traffic off of them, and they're fairly inexpensive to construct. The downside of them is that you have to do it on an annual basis, whereas with the rolling dips that we looked at previously, once those have been constructed, and if they've been constructed properly, you're looking at them functioning more on a decadal basis. I want to talk a little bit with you about surfacing of your roads. Oftentimes I've come onto properties and the land manager has surfaced their roads with what I commonly refer to as a single size class or drain rock. That type of surface works really well in fairly flat parking area or driveway settings where you don't want your users getting out of their vehicle and getting their feet muddy. But on roads that have any sort of grade to them or steepness, it's not a good material to use. It's basically once you put that type of material on those steeper roads, it's like driving over marbles. A lot of the vineyard properties that we work on in Napa County have day laborers coming onto the property on their own with their own vehicles. Oftentimes those vehicles are two-wheel drive vehicles, and therefore they're trying to come up these steep roads with this drain rock on them, and their tires start to spin out, promoting washboard. It reduces or it, tends to chew up the tires quite a bit, and it just makes steeper roads less passable, really. The other element to this is that this drain rock has no ability to really interlock with itself unless it's compacted into the native soils. And so over time, as vehicles drive these roads, that material is getting pushed off to the sides of the road. And so all this material that you spent money to apply is now on the outside edges of the road or in between the tires and no longer on the surface that you're driving. So what I recommend to landowners if they're looking at surfacing their road beds is using what's commonly referred to as 1.5 minus aggregate base or class 2 road base rock. 1.5 minus is meaning that the largest diameter of the material that you have on there is 1.5, and then the minus going all the way down to a sand or silt size range class. And that having those different size classes mixed together really helps it all to lock together really nicely and stay in place. This road's been tract walked with a dozer. You can roll it with a vibrating roller to really ensure that they stay in place. And again, I recommend about a 4-inch depth and maybe only a 12-foot width, whereas you can see in this roadbed they've rocked the entire width. That 12-foot width should be enough for you to have a single vehicle passage on these road beds. And the other thing I would point out to you is that 1.5 minus, make sure it's aggregate based. You can also purchase an 1.5 minus that a quarry can mix in with other types of soil materials and won't be as resistant to wear on a road system as having an aggregate base. I think also that, and you would want to check with your local quarry, but more often than not, this 1.5 minus is going to be less expensive for you to purchase than purchasing a drain rock. So it's another thing to think about. So those were kind of all those concepts that we talked about sort of fall into the category of road upgrading for stormproofing. Upgrading meaning that we're wanting to maintain our road systems for vehicle passage. What we run into a lot in coastal watersheds in California, oftentimes, especially in timbered properties, is that there's a lot of legacy road infrastructure. And so I want to kind of briefly go over two other categories of road stormproofing for you. One of which is what we often refer to as road decommissioning. Often when I start to bring up the term of decommissioning with folks, they start to look at it as a permanent restriction to access to that portion of the property. But what I would argue is that it's really more of a long-term winterization practice. This is something that's been implemented on larger timber properties over the past decades where they have literally hundreds of miles and culverts to maintain and manage over their winter time. So if they have an area on their property that they know they don't really need access to for the decadal or long-term purpose, what we recommend to them is decommissioning the stream crossings, which means removing the culverts or whatever other drainage feature there was there, laying the slopes back to a stable slope angle, decompacting the road beds, maybe putting some mulch on there, and constructing some large cross drains that we're not worried about drivability on, so that the road can be more self-maintaining from a winterization standpoint. And then if over time the landowner decided that they did need to go back out into that portion of their property, the road prism is still there, the streams are still there flowing, and they can go back and install culverts and smooth out the road so that they're drivable. This is a more cost-effective way to treat roads than, say, the upgrading, because you're not having to be more detailed with worrying about the drivability of the roadbed, but what you've done is really helped to reduce the amount of sediments that's coming off these roads. These road systems, especially if you're on a property that maybe has legacy road systems that you're no longer using, even though you're not driving them, they can be slowly failing and eroding over time, especially if they have culverts or other infrastructure that tends to rust out. And so therefore they are producing sediment and impeding water quality, but nobody really knows that because nobody's using the road system. So this is another way to really be able to go out there, treat some stuff, be able to walk away from it and understand that it's gonna take care of itself. The other element to this road decommissioning or the long-term winterization is it might be something you'd want to consider if you have trespass issues on your property. This would be a way to prevent people from getting onto your property or accessing areas that you don't want them to. And then thirdly, of these three groups of road stormproofing categories would be what we commonly refer to as road to trail conversion. And so in this instance, we have a legacy road system on this property that they no longer needed for vehicle traffic, but they wanted to retain access for, say, mountain biking, hiking. Maybe they only need an ATV to get out to a certain portion of their property. And so they don't need this 12 to 15 foot wide roadbed. They just needed more of like a 6-foot road prism. So in this instance, we've removed the culverted stream crossing and brought our road prism, which is only about a 6-foot width, further back into the stream channel, constructed one of these armored fills that we looked at earlier in the presentation, and then have the road continue out on its original path. And so what we've done here is we've really reduced the amount of sediment that's in this stream crossing, which helps for the water quality, but we retain the access for the user. And so this road to trail conversion you can kind of look at as a hybrid between the road upgrading practices as well as the road decommissioning practices. Thirdly, I think that these road to trail conversions can offer a nice aesthetic to your user. So that's another component that you can think about. And that's it for my presentation. Thank you for your time, and I hope it was educational.
You can find more informative presentations covering ranch water quality topics on the UC Rangelands website, and look for the Water Quality Information Hub or direct your web browser to the URL shown on this slide.